Hello everyone, we'll be discussing about the topic sustainable carbon nanomaterials, recent advances and its application in energy and environmental remediation. What is carbon nanomaterials? Carbon nanomaterials speak to one of the most assorted classes of materials with outstanding scope of properties which make them appropriate for applications in far-reaching regions of research. There is a sharp need to search for new carbon nanostructures by means of manageable and minimal effort strategies, understanding their job in vitality and ecological applications. The vast majority of the customary planning methodologies include vitally concentrated conditions and sequentially significant expense of creation. Union of carbon nanomaterials through high-tech system infer extraordinary importance. Now we come to the preparation of carbon nanomaterials using sustainable resources. The first being carbon nanotubes and related structures, graphene and related structures, graphene quantum dots and carbon dots. These are a few preparation of carbon nanomaterials which can be prepared using sustainable resources. Now coming to the applications of it. The first being adsorbents in water purification and gas uptake. The plan of an equipped adsorbent material for the detachment and end of modern toxins from squandered water is one of the significant difficulties in cleaning water. A productive adsorbent ought to have quick adsorption energy, better selectivity, and greater adsorption limit with regards to the evacuation of huge measured particles. The structure of a skilled adsorbent material for the division and disposal of modern toxins from squandered water is one of the significant difficulties in water sanitization. An effective adsorbent ought to have quick adsorbent energy, better selectivity, and great adsorption limit with regards to the evacuation of huge measured atoms. A wide variety of adsorbent for the removal of organic dyes have been prepared using carbon nanomaterials such as carbon nanotubes, graphenes, activated carbons, etc. Now we come to the second application of it, which is electrocatalysis. The utilization of graphitic carbon nanostructures GCN have pulled in extraordinary arrangement of consideration as impetus bolsters in oxygen electroreduction happening in energy units. Designing cost-effective electrocatalysts is the key in developing economically and high-performance fuel cell and metal air batteries. Sevilla M employed sawdust-based GCNs, which is graphitic carbon nanostructures, as electrocatalyst support for methanol oxidation reactions. The sawdust particle impregnated with Ni and Fe salt were carbonized at 900 and 1000 degrees centigrades respectively to obtain GCNs. It was used as support for making platinum electrocatalysts. It exhibited good distribution of platinum nanoparticle and the particle sizes were in the range of 2 to 3 nanometers. CV was used to measure the electroactive surface area, which was found to be 90 meters square per gram of platinum, and the electroactivity was estimated to be nearly about 250 ampere per gram of platinum. Now we come to the third application, which is in energy storage. There is a regularly expanding request to grow new sustainable advances to fulfill the expanding vitality needs. Alongside this, a vigorous practical vitality stockpiling frame is similarly significant. In vitality, stockpiling gadgets supercapacitor are better than batteries as far as force thickness, great reversibility and long cycle life. The synthesis steps involved a pre-treatment of biomass species, nitrogen pyrolysis and subsequent high temperature thermal chemical flash exfoliation. High oxygen functionality was exhibited by the material in form of electrochemically active quinone and pyrrole surface group. The presence of highly active surface functional group along with the high specific surface area, which is 543.7 meter square per gram, resulted in an improved capacitive performance with a capacitance of 221 farad per gram, which was 100 times greater than the natural biochar. The electrodes fabricated from exfoliated biochar had no conductive additives in it, and yet it showed an excellent rate capability, holding back 78% of the loaded capacitance at a fast discharge value of 40 ampere per gram. This blend of high capacitance and fast charge discharge capability differentiate this material from other high surface area activated carbon and other carbon nanomaterials such as graphene. Now we come to the conclusion and the future perspectives. Point 1. It gives an overview of various sustainable carbon nanostructures derived from cost-effective resources, especially biomass and waste residues like used up polymer plastics. Point 2. Extraordinary spotlight is on the technique received for the green amalgamation of materials like graphenes, like structures, CNTs, CDs, and different permeable carbon nanostructures. Third point. It likewise gives knowledge to a portion of the potential uses of these materials in sustainable power sources and ecologically remediation. The genuine test lies in creating manageable material without causing any natural concerns while guaranteeing better yields and execution. Point 4. Despite the fact that there are a great deal of traditional engineered technique embraced for the creation of carbon nanomaterials, the vast majority of them have constraints as far as enormous scope creation, notwithstanding the utilization of costly and dangerous synthetic compounds. That's all, guys. Thank you so much.